this problem is search in rotated sorted array. Given array sorted in ascending order, also with distinct values. Possible rotate at unknown pivot, index k, such that the array is from the k to the end, and the first 2k minus 1 will be rotated at this pivot, become this one. Given this array after possible rotation, and our target returns the index of target if it's in the numbers, or -1 if not it's not in the nums. Right, the algorithm with log runtime complexity. So this implies we will need to use binary search. Let's find the examples. For this example, if the target is 0, it should return the index 4. 3 is not inside, return negative. Okay, so one solution will be to find the pivot, and through that pivot we know the left and the right part will be the run the BFS to run the binary search to that part, to find the target. This is one one solution. The other one is we directly run the binary search on these rotated numbers. But we need to know. Let's say we have a middle like this one. Let's use this example here. So this is our input, and this is the left point, and right one. And we have a middle one. Let's say middle here. So we need to know which part is sorted. How to do this one? We can compare the middle one with the left one. If the middle is larger than the left part, which means the left part is guaranteed is sorted. Otherwise, if the right part, we need to find which part is sorted, and we can use a binary search during that one. Let's try to do it. So define the boundary as usual. This is the space. This is the middle. First we need to find which part is this is a happy case. If the numbers middle equal to target, we can directly return this index. If not this case, middle larger than numbers left. This one, the left part is sorted. Okay, the left part is sorted. Let's further check if the target is inside this range. The left one is target, and target is less than numbers middle. In this case, we are guaranteed no the target inside this sorted part, so we can shrunk our right pointer to the middle -1. If not this case, the left one left boundary will be updated. So else branch, this is the right part. Right part is sorted. Let's see. The middle now is moved to here. This is my middle now. So it's not sorted on this part, so it's guaranteed this part is sorted. The way is to check if the numbers middle is and the target also inside this boundary, which means the left part can be updated here. Otherwise, it's not inside this part. The right point can be updated. This is two cases here. If we never reach this part, I mean the return 1, and eventually we will return -1 here. Oh, let's write and submit it. Oh, it shows some wrong thing here. If the target, this case, left, right, so middle is on the 3. Let's directly use this one. Left, right, and the middle will be here. So if the middle is not the same, and I go to here, 3 is not greater, so which means the left part is not sorted. So we go to this branch, the right part is sorted. So let's define here, the middle is 3, target is 1, so it's the middle greater than, not smaller than target, right? So we go to this branch, and the right one will go to the -1. In that case, they will not meet, and it will go outside the loop and it directly return -1, but we need the answer will be 1. How can we learn from this example? The middle is not equal, so the middle's target. Oh, we need to check the middle with target first. So like this one. If the middle is smaller than the target, let's think like this one, the larger than target, so everything should be on the left part. Now we check the middle and the left one to give these things, right? So let's say if the left the middle is larger than the this one. Yes, larger than this one. So we are interested into the right part. So here it should be we're talking about the left part. So if the middle is too small. Oh, it's too should be like this one. Let's say the middle is larger than target, so means imply error should be on the left part. Not guarantee, right? So how to deal with this one? For example, it's middle here, middle and target. If your target is to find 2, we're not guaranteed to go which way. So my issue now is we do this check first, or we do this check first. This is my current thought process. Let's say if we do check this one first, so the middle here is larger than the target. So you don't know which way you're going to, right? Under this situation, next we check the left part is sorted. I mean, how to dealing with this one? If the middle is larger, this example middle here, let's say the t is to looking 0, and this is the middle. Now middle, let's check middle is larger than, so the left part is larger, it's sorted, and okay, if this one is sorted and our target is not inside this one, right? So our left part will go to the right. This is right. And another situation, it's middle too small. Let's see, the middle now is -1. This is our middle, and our target will be 0. This one is not sorted, so I directly go to the right part. The right part. I need to check this one. If numbers middle is smaller than numbers right, yes, this right part. This is only one possibility. Else, if this part is sorted, and under this condition, if the target is following this part, I can guarantee update the left part, else it's the right one. But what if this one didn't go through? Okay, it's guaranteed it's middle. Let's see, here it's still 7. Does this possible? I mean, do I miss any possible solution here? This is let's to write it very clearly to help us. So in this case, the middle one is too small to our target. So middle one is one smaller than our target. Now what we do is too small, which means we will potentially look in the right part. But what if the target we are looking for is 7? Actually, it's on the left part. But here we're still looking the middle and the right part to make sure it's descending. It's ordered. Yes, it's ordered, and the target is not in this one. We can also update the right part to this one, and we'll continue researching this search space, which is great. So let me run this one. Okay, the time exceeded. We have infinite loop. This is what I'm worried about here. We only have this branch, and this is this 2 main branch, and under this if condition. If this one inside this, how do I know which part is sorted or not? This is to identify which part is sorted. If it's have possibility we don't follow in this if branch, how do I deal that part? Which means the target, the middle point, it's not the point, I think. We don't need to consider this because let's return to the previous version. This one, we only consider the middle and the left part, else the right part, and consider this one. If we don't care about the target with the middle one, the target part will follow in the below. So the thing we are interested in only is left part is sorted or not. If this one satisfies, the left part is sorted. Left part is sorted, and we check the target following the left part. If it is, update the right part, right boundary. Else, it's not in here. It must be into the right part. So update the left boundary. Else, so in this case, the right part is sorted. If we are lucky, the target fall into this one, it will directly update the left part. Else, if not, update the right one, right pointer. This one, I believe, make more sense to me. Let me fix this part. This is the case we don't pass. How do we dealing with this one? The middle point is here, left, right, middle, start, yes, it's greater, middle, it's the same thing. Do we add the left, right part? If we add more condition, is it good to check? Left, middle. So why will this happen? Let's figure out. Let's figure out this one. The left, right, middle here. Middle is larger than the target. Middle is not larger than left one, which means in this condition we are going to the right part. Okay, let's move the equal sign here, because our middle is, we'll consider the floor about these two, the average of these two boundary. So if it's equal, let's make it to the left part and try to write. Now it works and it passed. So the point is to not compare to the target with the middle, because even we know we don't necessarily know which part we're going on. So the way we are looking is to compare which part is sorted or not. Tricky part is you need to assign the equal sign here, because the middle point is floor to the in flavor to the left part. So there's a chance in this case we will treat, in this case the left part is sorted, and do the stuff in the left part. Let me check what I'm previously right. It's the same thing, and you need to be careful like this one. Okay. See this one? Left, middle, left. So you need to make sure this equal sign is to the left part and not to the right part. That's the thing you need to look out. Finally, check this one. Pivot. Yes, this is the first way to do it. Find the pivot, then run the binary search to the two different parts. And it will still be log n. Binary search will shift. One binary search is like us here, it's middle. Summary on middle's left is sorted. See, you need to this equal sign to the left part. Else subarray on middle's right is sorted. Okay. I think that's it.